So let's look at similarity. Now we've seen congruence, meaning two objects have the exact same size and shape. Similarity is close to that. Similarity, we're looking at polygons with the same shape, but a different size. So what that means is the shape is going to come from the angles. So we still have corresponding angles being congruent, but now since it's a different size, it's the sides that are not congruent, but what we call proportional. So same shape, different size, angles are congruent, sides are proportional. And what a proportion is we'll get to in a moment. Now, whenever we talk about similarity, we want to have a similarity statement. That is telling us our two triangles are similar. The similar symbol is right there. It's kind of like the congruence without the equal sign. So I'm saying that A, B, C, and D, E, F are similar. So let's look at the angles. Now, angles are congruent. So we could say angle A is congruent to angle D. We could say angle B is congruent to angle E. And last, angle C is congruent to angle F. But when we go to sides, it's a little different. So sides are proportional. Proportional means you can set ratios equal to one another. So if I said AB as one of the sides, AB is corresponding to DE. That's one ratio. BC, another side, is corresponding to EF. And then the third set of sides are AC and DF. Now, all of those are equal to each other, and that's what makes it proportional. But we also have a value that we're going to call the scale factor, and that's going to be a value that all of those fractions are equal to, and it's a kind of a quick way to describe the relationship between the two objects. So we already have values drawn in, so let's replace our segment names with the values and look at what that means. So AB, I have labeled there is 3, so we're going to go 3 over 9. BC is 5, and then over 15, and 4 over 12. And again, I'm just matching 3 is to 9, as 5 is to 15, as 4 is to 12. Now, all of those fractions are equivalent because they all equal 1/3. So we would say in this case that 1/3 is the scale factor. So the angles are going to be congruent, the sides being proportional, meaning they all equal a scale factor, or all equivalent to each other. If they're not equal to each other, so let's say this one happened to be 1/4, then we would just say that they are not similar triangles. So let's kind of work through some of the basics and kind of build upon and start to solve. So I have two similar triangles here. I first need to name the angles. So I have angle J is in the first triangle. That is congruent to angle, if I look at the name, J and P are both the first letters, so that's P. Angle K is going to be congruent to angle M. Those are both the second letters. And then the last letters, L, is congruent to angle N. So there's my angles. Those are set. Now when I go over to the sides, a common rule we're going to use is whichever triangle is listed first, we're going to write those values on the top of the fraction. Whichever one's listed second, those values will be on the bottom. So if I look at the first triangle, I have JK, KL, and JL. And that's just going in order of first and second letter, second and third letters, first and third letters. Now all of those are going to be proportional, or matching, to their corresponding value. So JK matches to PM, KL matches to MN, and JL matches to PN. So now we can take that, we go down and we start to solve in our next problem. So I have DEF and HJG. So what I'm going to do first is I'm going to name all of the sides and then substitute values. So DE is the first two letters. I'm going to match that to HJ. EF is second and third letters. That matches to JG. And then DF is going to match to HG. So now I copy it over the values. We have 9 over 15, 14 over Y, and 12 over X. So from these, I always have one value that works that's already known, and that's the 9 over 15. That reduces to be 3/5. Now that is also our scale factor. So if I took 3/5, I could set it equal to both of the other fractions where I'm missing a value. And looking at that, the one for x is actually a lot easier to solve because besides cross product, 3 times 4 gives me 12. So that means 5 times 4 would give me 20 because the fractions are equivalent. If you don't see that, we can always go back to cross product. So that would be 3x equals 5 times 12, or 3x equals 60 to give us x equals 20. And the other one, 3 times what value giving 14, isn't going to be as a whole number, but we can still solve. 3y equals 5 times 14. 3y equals 70, and so y is 70 over 3. Fraction, we can write it as a reduced fraction. That answer works for us. So now we go and we're going to do this some more, but we have some different types of triangles showing up. So I have XYZ and RYS. XYZ is the whole triangle. RYS is the smaller one. Now they're overlapping, and we'll use this later, but this Y right here is reflexive. It's in both triangles. So it's a little triangle, big triangle overlapping. But more so when I name angles and sides, I'm just going to use the names that are here to help me. So like X is congruent to R. Y is congruent to Y. That's our reflexive one. And then Z is congruent to S. But the problem here is when I name them, I don't know which angle R and S I'm talking about. So we need to go back and change the names of R and S to use 3 letters because you've got to be careful with how we name the angles. So X should be corresponding to YRS, and then Z is corresponding to RSY. Now for our sides. So I'm going to go XY is the first 2 letters, YZ is the second and third, XZ is first and third. So now we match. RY goes to XY, YZ goes to YS, and XZ goes to RS. Come over here, we're going to solve in the top right. AB here matches to DE. So 25 over X is equal to 20 over 28. Now whenever you come across this, I would reduce the fractions if possible. So this is going to become 5/7 whenever I reduce 20 over 28. Now I can look at it and say, well, 5 times 5 is 25, so 7 times 5 should give me x, which in this case would be 35. Or you do cross product and you get 5x equals 175. X comes out to be 35. Next problem, we have AG is 32. 32 is to KX, their first and second letter, so that's over x plus 3. And then 36 over x plus 6. Now I'm going to do cross product. We get 32 times x plus 6 equals 36 times x plus 3. Now I don't want to make it more complicated to solve here, but what I can do is I can divide the 32 and the 36 each by 4. In doing that, it gives me 8 times x plus 6 and 9 times x plus 3. Then we distribute, we get 8x plus 48 equals 9x plus 27. We can subtract the 8x over, subtract the 27, and we get 21 equals x. Next we go to the middle right. We have TL is 25. That matches to CH, both first 2 letters. So 25 over 10 is equal to 4x minus 1 over x plus 5. I'm going to reduce 25 over 10 to make it 5 over 2. I can't reduce 4x minus 1 and over x plus 5 because it's not, there's no factorable. So we do cross product. We have 5 times x plus 5 equals 2 times 4x minus 1. Gives us 5x plus 25 and 8x minus 2. We subtract the 5x, we get 3x. we add over the 2, we get 27. So 3x equals 27, and x equals 9. Our next problem, the bottom left, we need to find the value of x. So let's see. Kn is the second and third letters. That goes to KL, which KL is the whole thing. We need to make that 32. Because we're talking about little triangle, big triangle, we have to take the total of the side. So let's go this. Let's go 12 over 32, little triangle over big triangle, equals x plus 1 over 3x minus 2. Now 12 over 32 does reduce. I can divide them both by 4, and I get 3/8 equals x plus 1 over 3x minus 2. By cross product, we then have 3 times 3x minus 2 equals 8 times x plus 1. 9x minus 6 equals 8x plus 8. I'm going to subtract an 8x over. That gives me x. And then add 6, and I get x equals 14. For our last one, we're going to do a similar idea here. We're going to go little triangle, big triangle. I'm not going to use the name this time. Let's go. 20 is to 28 as 15 is to 2x plus 3. 20 over 28 reduces to be 5/7 equals 15 over 2x plus 3. By cross product, we get 5 times 2x plus 3 equals 7 times 15. What we can do here is divide both sides by 5, and what this gives me is 2x plus 3 equals 7 times 3, because that becomes a 3. So it's 21. We subtract 3, we get 2x equals 18, and x equals 9.